Hello, this is Dr. Donald Barnhart, and I'm here to talk about a new integration for Optica with BeamWise. My goal with Optica was to provide an interactive design environment for rapid design space exploration and optimization. What is exciting about BeamWise is that it brings these same capabilities to the mechanical aspects of a design. BeamWise allows you to manage mechanical constraints with interference checking and the correct attachment of mounts and fixtures. BeamWise complements Optica by providing links to online catalog information about optical components, in particular 3D mechanical models that can be manipulated on a virtual optical bench. Now, in addition to your ability to share interactive Optica models with your colleagues, you will be able to give them 3D mechanical models, a costed bill of materials, and final assembly drawings. In this video, I would like to take you through a quick example of Optica and BeamWise working together to define and optimize a stable ring resonator. Initially, we will sketch a simple layout of the optical components in BeamWise. Next, simulate and optimize the design in Optica, and finally, return the optimized design to BeamWise to add mounts and create a costed bill of materials. BeamWise allows you to select actual catalog components or to use generic placeholders that can be substituted for real components later. You can defer the selection of supporting components like mounts until the optical design has been completed. BeamWise relies on the location and direction of the beams in the design to position and maintain the correct relationships between components. It automatically adjusts mirrors and beam splitters to the correct angle. We now have a sketch of the layout with the lenses in roughly the right position. It's time to transfer the design to Optica, simulate the performance, and optimize where needed. With Optica, you can interactively visualize and optimize your designs in real time. In addition, you can share these interactive models with colleagues for feedback and design reviews. First, we import the initial design from BeamWise to create the interactive model in Optica. Once the Optica model is set up, there are three ways you can interact with it. Either by adjusting its sliders, by manipulating the graphics, or by optimizing one or more merit functions. In order to perform an optimization, you must first select a merit function and then choose the parameters to be adjusted. In this example, our goal is to create a stable ring cavity resonator where the round-trip wavefront is matched. This will require two different types of optimization, one for beam centration and the other for beam flatness at the output coupler. In this case, the laser beam enters the cavity from the left side, travels counterclockwise around the cavity, and exits through the bottom of the coupler. First, we optimize for beam centration by adjusting the height of the incoming laser beam, which is given by Y laser, as well as adjusting the beam splitter height, which is given by Y splitter. To do the first optimization, we simply click on the corresponding tab, in this case for beam centration. Next, we optimize the parameters for Y laser and Y splitter. In this case, we need to unselect the parameters that we are not going to use, such that only Y laser and Y splitter are left selected as parameters. Finally, we click on the Optimize button. After a short while, the optimization has ended, and we can go back to the top view screen in order to see that the beams are in fact overlapping at the coupler. This optimization now has the beams concentric. Next, we optimize for beam flatness by selecting the Beam Flatness tab. We now only need to optimize for one lens position in order to get a fully optimized beam flatness. In this case, we will use the Y lens parameter, and we will unselect the remaining parameters. Now we click on the Optimize button, and in almost no time, it has found the correct position for the lens. Going back to top view, we can see that the overlap is extremely good and it's flat. We can also look at other types of perspectives, such as using full 3D to see the optical design in 3 dimensions, as well as looking at the optical path difference, the OPD, at the output coupler to confirm the optical flatness of the propagated beam. Finally, we send back the optimized results to BeamWise for mechanical fixturing and final documentation. We import the optimized design from Optica into BeamWise, and we see 2 optimization improvements have now been included in the layout. The upper lens and the beam splitter have moved to new locations. We are ready to add mounts to the layout to have a final specification for building this on an optical bench. For the beam splitter, we show the step-by-step process of adding a mount, its post, and post holder. For the first lens, we select a lens tube and then rotate the lens tube to allow the full lens mounting assembly to fit next to the beam splitter. Next, we select an appropriate attachment point and add a mount, post, and post holder. For both mirrors, we rely on the default support structure so that we only need to specify the part numbers of the supports. Every actual component has a catalog page URL that you can check at any stage of the design process for more information. Next, we generate an assembly drawing. This is a one-click process in BeamWise. You can export the design layout to SOLIDWORKS as a 3D model at any time as well. Now we have shown you how Optica and BeamWise work together to provide you with a path from an idea to a working optical design that has been simulated and optimized and is ready for your product development process. For more information, visit us at opticasoftware.com or beamwise.net.